Give this man a warm applause, please. Thank you.
Cool, thanks, Job. So I like pictures, so there's quite a lot of pictures in this presentation. And this one is a great example of what happens when big electrics go wrong. So this was the New York City skyline at the start of the year, where an extra high voltage, so 400,000 volts and higher, transformer failed and didn't disconnect. It lit up the night sky, and actually photographers would have loved that. It was a great evening to take pictures. But when it goes wrong in a big way. So I'm Steve Wright. I operate the data centers for a company called 4D over in the UK. We've got a couple of buildings just around London. And this presentation came about purely because we had an accidental FM200 discharge. And not many people talk about that. So it's one of those things, quite interested to hear other people's experiences. This is ultimately what we're trying to prevent. When your network monitoring system says high temperature alert, you're thinking, oh, one of the data centers got some air conditioning problems, not you ending up with a charred, gooey mess of equipment. So when we talk about fire suppression, that's the aim. Whether it actually works all the time, that's a debatable question. So, a couple of quick questions. Who here is familiar with data centers and has seen fire suppression systems in them? Okay. Who in the room has been in a data center when the fire alarm's gone off? And you all left straight away, didn't you? And has anyone been in a data center when the actual fire suppression system has gone off? Cool. So we got a couple of people. It's interesting, isn't it? So get some beers for those guys later. Can't remember. Got to see who that is. Interesting, dangerous, scary, many things. So it doesn't happen all that often, and there's not a lot of experience surrounding it. So, quick rundown of the presentation. We've got to cover some fire basics, and it is truly back to school science lessons. Quick discussion on detecting fires, then actually how we suppress them, the after effects of a discharge, and fundamentally, one of the questions I'm putting out to the industry is fire suppression actually worth it? We install it a lot of the time, but are we installing it and asking for it to be installed in the right places? So, I'm sure you all remember from your basic science lessons, we've got the fire triangle. We need three things to create a fire: oxygen, heat, and a fuel source. When we're looking at fire suppression, we have that basic triangle, but we do have to add one more factor to it. And that's the chain reaction between those three pieces. So this is the fire tetrahedron, and without that chain reaction, you can't have a fire. That becomes kind of important when we start talking about the various suppression systems. Detection, obviously knowing about problems. When we look at our network equipment, you're always thinking, right, I want to know what's being utilized, what alarms it's generating, what errors it's got going on. Sort of the same when you're in a data center. You want to know exactly what's happening with your power, your cooling, your air quality, et cetera, et cetera. So we've got a number of different types of detectors. So you have optical and ionizing. These are the most basic of detectors, really. You have these at home. Generally, at home, there'll be an integrated single device. So optical literally has an infrared beam, and as particles pass through it from smoke or the such, that causes that light to reflect onto a mirror, activates the alarm. Ionizing, similar reflective element of particles getting involved and a detector beam or a detector plate seeing those charged particles. Now, in data centers, you'll often hear about VESDA or IFD, so VESDA being very early smoke detection apparatus, or IFD, incipient fire detection systems. So these are basically sniffing the air constantly, and you'll see the red pipes generally around the top of air conditioning units or anywhere where there's a good airflow going. Now these systems are super, super sensitive, anywhere between 500 to 1,000 times more sensitive than the optical and ionizing smoke detector heads. And if you look at fire development, there are distinct stages in that fire development. And importantly, with the VESDA system, and at the incipient stage of a fire, there are small particles being given off. And this is before it's started to generate heat or lots of black smoke or the such. And a VESDA system will create a thing called generally a VESDA alert or a VESDA pre-alarm, saying, something's going on with the air quality. Chances are we're detecting the very early stages of combustion. And as that progresses through the stages, going to VESDA action, and then VESDA fire, and then it can be quite a bit of time before a smoke detector head, so one of those ionizing or optical heads, will actually detect a true plume of smoke. So there is a big stage there of what do you do when you get a VESDA alarm. Most data center operators send people to investigate it, and that's the sensible thing to do because you know it's in the very, very early stages. VESDAs go off a lot. The magic smoke coming out the back of a power supply is probably the #1 cause of activations of VESDAs. But it's really important, if anyone from operational data centers are here, that your teams are well trained and don't become a bit numb to any noise that they might think come off the VESDAs. So, quickly on the fire suppression side. So you've got 3 main types. Obviously, we all know about water. It's the most common. In data centers, we obviously don't really like water all that much. We've got the option of reducing the oxygen down, and we've got interrupting that chemical reaction. So I've never deployed a water fire suppression system in a data center. I've seen it done in a few places. As I understand it from speaking to people that have done that, they're more interested in protecting the building rather than the IT equipment. And that's a sensible and reasonable approach. Oxygen reduction, so don't be alarmed by this. Under about 12% oxygen levels in a room, a fire can't combust anymore. So that's your aim with 2 types of system. You've got argonite and inogen. They're basically aiming to reduce the level in the room down to between 10 and 11%. That way the fire will naturally extinguish itself because there isn't the oxygen there. It's perfectly fine to be in that room. Humans can carry on breathing, you stay alive. However, if you do have any pre-existing medical conditions, it could aggravate them a tiny bit. But if you're in good health, there shouldn't be any issues. And then finally, referring to the chemical aspects of fire suppression. So importantly, that fire tetrahedron, that chain reaction. So the products of FM200 and Novec 1230, they actually interrupt that chain reaction and stop the 3 components interacting with each other to prevent a fire. So once again, these are not harmful to humans. Now, they're not the best for the environment. And there's always been rumors of people going, oh, well, we had to get rid of halon because it was really dangerous if you were in the room when halon went off. That's not true. It's going to be unpleasant, but it's not going to kill you. And it is still the most effective fire suppressant. Out of all the systems that have been, and chemicals that have been developed since, it's still used a lot in planes because the space it takes up is really compact. However, polar bears really don't like it because it kills them off. Terrible jokes, I know. So we put all of this together. You've got all your detection and all your alarming and your suppression system. So you got your VESDA, and it's gone, oh, I've seen a pre-alarm. So, we've got to immediately respond to that. Jumps into fire. Oh, that's not a great situation, but okay, get the building evacuated, have your fire marshals go and check everything out. You get to a first knock, that means one of your detector heads has detected something like smoke, and then you're like, okay, this is kind of getting serious. A second knock, that will then generally activate your fire suppression system. In between 30 and 60 seconds, whatever suppression system you've got is going to start discharging. And a system discharge is pretty expensive, depending on the size of the system. Our one, I think we deployed in the region of 250 kilos of FM200, cost the best part of £50,000. So they're not cheap. And as ever, everything always comes back to a chain reaction. I looked at the fire tetrahedron, and when I was reviewing the situation that we went through, it was actually what was the underlying causes. We have to understand what happened to be able to prevent it from happening in the future. So we had a 1 in 1 million failure, according to Tycho. A firing mechanism on one of the big red FM200 cylinders failed. That then activated the release of the FM200 chemical, out of that cylinder. Okay, not the end of the world, it's a bit pricey, but if it was just one cylinder, that would have been fine. But then a design element, which hadn't really been taken into consideration, it's probably on me as part of the design team, we had the FM200 nozzles around the data center. But we didn't take into consideration where the detector heads were and the pipe routing from that single cylinder of FM200. And it hit 2 detectors. So we jumped from having nothing happening to a full second stage or double knock situation, second stage alarm, and activation of the fire suppression system within about a second and a half. Doesn't give you a lot of time to start thinking about, right, okay, is there really a fire or how to respond? We've since done some very good scenario planning and analysis on this with our teams. Now, you get some interesting side effects from fire suppression systems going off. So this was a great one from someone that sent me some pictures of, they actually had 2 accidental discharges in the same month, which is pretty unfortunate. One of them was truly accidental. The second one was the fire servicing company had come in and replaced everything, went to put the system back into live, but they hadn't reset the previous trigger, so it released the whole system again, which if I was an insurer, I would be asking them some serious questions. But interesting side effect. Because of the release and the pressures of all of these elements and the speed of release, it caused the pipes to freeze. So not really a problem in like your plant space area where you might have your cylinders stored. Kind of a big problem if you've got false ceiling tiles with pipes running above them in your data center, particularly when it starts to thaw out and you start getting dripping pipes all over your equipment. That's not a great thing. Air conditioning has some interesting effects. So for these fire suppression systems to be effective, you need the room to be able to have a hold time and a containment time. And you'll hear about integrity tests being done, and basically you'll pressurize the room and see how long it can hold that pressure. If you're using a direct adiabatic system, so using fresh air cooling into the data center, well, you have to stop doing that for a period of time. And so one of the examples someone sent me was they had an accidental discharge and then sent me their graphs of their air conditioning of all of their temperatures starting to creep up and them having to make a very quick decision about, right, is there a fire in the room which we can't technically go into at the moment? And can we open up all the venting and turn the aircon back on? So that's just another side effect to be conscious of. Hard drives. So I think it was an ING institution in Eastern Europe where they had, once again, another accidental discharge, but the pressure wave was huge and created a really high whistle. That knocked out all of their storage platforms. And so there's then some research done, and you'll see sort of special data center nozzles for fire suppression systems now. But likewise, some of the hard drive manufacturers had to do some investigations about, okay, what is the upper limit? Apparently it's about 110 decibels. Hard drives get really upset. There's an interesting YouTube video of someone saying, don't shout at your SAN when you get angry. It's worthwhile, because it was one of those things when I was investigating this. You can see disk latency increase every time you shout at your SAN, so it's not going to make it better. So in my accidental discharge, I was pretty sure there wasn't a fire in the data center, so I did everything that you're not meant to do, went into a sealed room. FM200, when you inhale it, gives you a really deep voice. I very much felt like Barry White when I came out to advise the rest of the team that there wasn't a fire. I was also slightly confused by who was speaking, because it was one of those... Who said that? But onto the more serious aspects, one of the reasons to not be in the room, it's not because the chemicals would ever cause you any damage or as such. You're dealing with high pressure. You know, the cylinders are generally charged anywhere from 100 to 200 bar of pressure. And so when they release, there's a lot of high pressure running through that pipework. If a cylinder isn't strapped down or the pipework isn't appropriately strapped down, it will move. And these are generally pretty heavy-duty steel pipes. You don't want to be hit by one of them. And as you can see, there's a couple of pictures that I got sent where mountings had ripped out of ceilings and walls, and pipework had twisted just through the force. So, talking about that element of the dangers of this, this was an incident that happened at a private data center in the UK that was undergoing refurbishment. Now, there's a few issues in this picture. So you see all these lovely cylinders lined up. Slight problem, none of them are strapped to the racking that they're meant to be strapped to. And you see the little silver caps on the floor. Yeah, those are pressure relief valves that are meant to be secured on the top of the cylinders when they aren't strapped to anything. So should anything happen to one of those cylinders, should it fall over, actually it won't start flying around. However, in this instance, one of those cylinders got knocked. It then caused a chain reaction into the other cylinders. So while that looks pretty bad, obviously the property could be repaired. That caused a number of fatalities. There was one guy who was killed from it. And I think there were 6 people that were in hospital with life-changing injuries. These are like mini missiles when they go off. So just being really conscious, and this element of when I'm saying really don't be in the room when something happens, just think back to this. Ultimately, there's found to be loads of health and safety breaches on this installation. The companies involved got fined over £1 million. And yeah, it sort of brings home that actually don't mess around with these systems. Make sure you've got experts maintaining them, people who are super competent. So, improvements. From my own experience and chatting with people, it's interesting. I've heard about a lot of accidental discharges. Not heard of many real-life fires actually in a data center on the data floor where the IT equipment is. UPS rooms, battery rooms, electrical switchgear rooms. Yeah, I've had some interesting stories of people come through with some nice explosions going on, but still nothing really on the data floor. So if you do have any stories, please let me know. I want to do a revision of this in a few years' time and include those stories. Hopefully there'll be no serious incidents like I've previously shown. On the people side, I think it's really important, as I say, of keeping our community safe, to just be conscious that don't ignore a fire alarm. It can be kind of serious. From your data center operator standpoint, it reinforced that the training element for my teams is really, really key in making sure they are able to make rational decisions in super high stressful alarm situations and trying to pare that down into simple bullet point guides on a single sheet of A4. So I'm happy to discuss that with anyone who operates data centers to try and actually get some industry best practice around this. So we can have some level of standardized process that has been risk assessed across everything. And once again, the training and drilling of this, it's one of those things. It doesn't happen very often, but it's like any major outage that you plan for. You deal with the situation, you do your incident frameworks, you do your desktop studies, but actually making sure everyone knows how to react is really key as well. So ultimately, is it worth it? As a multi-tenant data center operator, I still have to install it. A number of people treat it as a tick box exercise, but is it actually effective having FM200 or Argonite installed on the data floor? Or is it just a big waste of money? I'll leave that up to you guys to decide. So, any questions?
Hi, Rogier from i3d.net. You were asking for a real-life example of a data center fire.
Yes.
2002, University of Twente. Someone wanted to be a hero and started a fire in the building where the data center was, but couldn't get it out, and the whole building burned down.
But was that fire just in the building or actually in the data, actually caused by IT equipment?
It wasn't caused by IT equipment, but it burned down the whole data floor.
Yeah, so I'm guessing there wasn't a suppression system across the whole building, just on the data floor.
I think also not on the data floor.
Oh, okay.
This was 2002.
Okay, let me qualify my statement then. I haven't heard about a fire in a data center in the IT area that didn't have a fire suppression system in it or a fire suppression system that was effective to stop that. I know there's a few caveats there, but I haven't got a story to say where it was like, cool, yes, this fire suppression system did exactly what it was meant to do. It worked perfectly. It's always been, yeah, we had an accidental discharge, and oh no, yeah, it cost us a lot of money. It did some damage. Right, let's reload the system again and set it back into the same way it was before. That, to me, seems slightly insane. Yeah.
If you work in this industry long enough, we all end up with the stories of the accidental discharge. You've got it in a data center, it costs thousands of euros to refill it. It goes pop. How long does it take to refill it, rearm it, and isn't the data floor left with no protection in the meantime? And given that Murphy's Law says that if one piece of hardware fails, its friend's going to go in sympathy very shortly after, aren't we just basically protecting ourselves only from the first mistake?
So I can only really talk to FM200. So it is a CFC, and in terms of getting the quantity needed to refill our system, that took
Was that the sound of an FM200 discharge somewhere in Amsterdam?
It's considerably louder and a lot scarier. And it also creates a big white fog mist in the data floor, which sort of, if you're with some of the LEDs, you feel like you're in a bit of disco. Sorry, so the question on refill. So it is a CFC. There are now restrictions on importing FM200 into the EU, which is causing both supply challenges and price escalation. So yeah, it took, I think, about 4 weeks for us to get the quantity required. Actually, doing the change out of the cylinders isn't that much work with a strong engineering team. It's about a day and a half's work. In response to how you then protect against something happening, it's about re-drilling the team. You've still got your VESDA, so you've still got your detection apparatus. It's then making sure that your staffing levels, your manning levels are appropriate to that, and then ultimately having lots of CO2 fire extinguishers around. So if it is a small fire, it can be dealt with. But ultimately, as I tell my team, if there's a fire raging and you're in the room, get out the room. We can replace computers. We can replace buildings. I don't want to be the one that's having to speak to your parents and tell them that, yeah, I've accidentally killed your son or daughter.
Cool, thank you.
Thank you for your talk. These early detection systems, are they very sensitive to like carton dust? Because nowadays you cannot take a carton box in a data center anymore. Is that the reason?
Yeah, it has. There are levels of filters within VESDA systems. So it's primarily looking for incipient particle, which is caused by the combustion process. Some of the systems nowadays you can actually use for air quality monitoring as well. So there is an element where, from a general fire precautions, not having cardboard on the data floor is just good. But also the amount of dust and particulate when you open a server box is quite significant. And if you're getting that hundreds of boxes, thousands of boxes, that dirt will just build up on the inside of equipment. And it's just not a great environment to then be living in.
But is it, so it could be, there's a filter in it to take, because
yes.
You hear a lot about like fire alarms going off, also in tunnels and stuff, where like we had a train tunnel here in the Netherlands that was closed down all the time because fire alarm went off.
Yeah.
As of course, trains generate a lot of dust.
I don't think I've seen an unboxing situation where it's actually caused a VESDA to go into a
so it's the
alarm
accumulation of the dust.
Yeah, it's more accumulation rather than having a super dusty, massive box which would then set the system off as you start hacking into it with a knife or something.
Hi, I actually have a question about water mist. Do you have any experience with that? I've been to a tour for a big data center here in Amsterdam that make use of no other chemical then, but only water mist. I was a bit careful there about condensation, but apparently if the mist is very, very fine, it doesn't condensate or something, but it does cool down. I'm not sure. Do you have any knowledge of that?
So I've heard about those systems. I've never had first-hand experience of them. The high fog system, I think it's its commercial name, uses deionized water within it, and it's supposedly effective. I don't know, I'm still slightly dubious. Obviously it shouldn't conduct, but that concept of a lot of water all over a lot of electrics, for me is one of those things as a kid. I was taught not to put those two things together. It sort of still scares me a little bit. So without having any first-hand experience, as I say, I'm not an expert on the pros, cons, and risk factors of it.
Thank you.
That brings me on, I actually put water on a fire system that was under electricity. It was in a training situation. You can easily do that. When it's foamed water from a fire extinguisher, was 230 volt voltage on it, and nothing happened with me doing that.
You're a braver man than I am.
The fire went off. It was all in a training situation.
I had a situation where the alarm went off and I was in a dedicated room, but I didn't hear the alarm. And I was wondering if that was, if there was not like a standardization with like the tier 1, 2, 3, 4, whatever data center grade, where you need to validate that everyone will be able to hear the alarm and so on whenever like the fire alarm goes on and so on. I was wondering if that was like related to the tiering.
Yeah, there's. I'll put my hat on and say I can't stand the Uptime Institute tier levels.
Yep.
I don't think they're effective. I think
Uptime is optional.
Yeah. So I think people should. You can use it as a baseline of okay, this sort of data center, but in reality, actually do your appropriate due diligence and match the facility to your business need. On the standardization side, I'm not aware of anything specific. The challenge inside a data center, and particularly a multi-tenant data center operator, you've got all sorts of different types of equipment running different fan speeds, different noise levels. So what we have is also visual flashing bulbs. So there is a visual element to it as well. One of the things we found a number of years ago when one of the data centers was really starting to get towards its capacity, there was a separation between the building fire alarm, which was digital and speaker-based, and then for the fire suppression system was on bells. Now, the bells, actually when we went into some test scenarios, you just couldn't hear on the data floor anymore because the bells were just too quiet. And actually, we got to the point of standing pretty much underneath the bell and you couldn't hear it over the rest of the room noise. So it's probably something actually it's worthwhile as looking into as an industry to go, how can we effectively make people aware in these noisy environments about fire? There's also the classic thing of we all put our headphones in and have our music turned up to try and drown out the rest of the noise of the data center. So yeah, it's a lot of awareness elements have to be taken into account.
Okay, thank you.
No course. Cool. Thank you very much. I hope it won't get fire. Oh, awesome. One of the guys will like that.